The Bantam is a modern RoHS and CE current mode amplifier. It's like an old style amplifier. It does trapezoidal torque mode, good for motors with Halls, typically used in an application where an encoder would feed back to the controller. I've also used this amplifier to drive voice coils, DC brush motors. It's current mode or torque mode only. It does commutate with Halls, a brushless motor, but usually used inside another loop to control velocity and position. However, there is a mode to limit the PWM, so we can limit the top speed, sort of a poor man's speed controller. The Bantam can run on 12 to 55 volt. Doesn't mean a 12 volt battery. Maybe a 15 volt supply and typically 48 volt supply. Or 20 volts to 90, which means maybe a 24 volt battery system, up to 90 volts before shutdown, typically a 75 volt unregulated supply, or maybe an 85 volt regulated. It does 10 amps continuous 20 peak, or 5 amps continuous 10 amps peak. So we're going to see how to wire this thing to the development kit. So the module plugs into the development kit. So here's the development kit. I'm sorry, this is the module, and this is the wiring to the module. There's a heat plate which should be connected to earth, so all the switching noise goes to earth. There's a DC power supply which should be connected to earth near the drive with some capacitance typically. The brushless motor is 3-wire U, V, and W. If you had a brush motor, it connects to U and V. If you got a brushless motor, you'll have Halls, U, V, and W Halls, or 1, 2, 3 Halls, plus 5 and ground. So you wire the Halls in a logical manner. And for proper commutation, we'll have to swap motor wires. I'll explain that in a little bit here. And the analog command is a voltage, plus or minus 10 volts, typically commands plus or minus peak current. All the adjustments are done external to the drive. There's an enable input. There's limit switches for positive and negative limit. You can hook up a balance pot, but usually the AD control circuit regulates 0 volts. And you can configure peak and continuous current, I2T limit, and a PWM limit that limits the voltage to the motor and the speed using resistors external of the drive. One handy feature is the current monitor. This shows the current to the motor, and the current reference shows what you're commanding from your A to D converter. So we'll take a look at how to hook that up to a scope. So here is the Bantam. You'll notice it's smaller than my business card, but larger than a quarter. I've got a rugged Bantam here for the MIL 810F applications installed into the development kit. I've also got 24 volts with respect to ground wired and earth wired at the drive. I've connected my motor. There's 3 wires, so there's 6 possible ways to hook up the wires. There's Halls plus 5 and ground from the motor. This is a Lin Engineering motor with motor power wires and Halls. There is an encoder on the back for a control system, but we're not using that to control position or velocity today. And because I have the power turned on, I get a light. Everything's okay, no faults in the drive, and I have the Hall decode. As the motor turns, you can see the Hall states decoding. That tells you the Hall signals are good. I have connected here to my reference input sine wave from a function generator, plus or minus less than a volt, because I want to do small current or small torque testing. And I have my oscilloscope hooked up to the current monitor. If I enable the drive, I should get current out. The drive's enabled, but I don't have the positive and negative enable lines pulled to ground. I have the positive enable, so I can rotate forward. negative enabled, so I can rotate forward and reverse. And you can see on the scope I've got plus or minus a small amount of current going to the shaft of the motor. Now, if my motor wires are hooked up incorrectly, I would not be able to commutate in both directions with a small signal. So we'll take a look at how we do commutation in both directions in just a moment. There's a small potentiometer that can be adjusted for balance. I haven't had the need to adjust it because near zero it's pretty good. And the resistors that program the drive go into this little header socket here for peak and continuous current limits. So external of the drive is the programmability of current limits using resistors to program the drive. So the peak current limit resistor is selected from the table as a percentage of the drive's peak current. There's no resistor installed for full peak current. If you want to reduce the peak current, you can put in a resistor. So 50% of the peak current would be a 9.6 kilo ohm resistor or 2.4 volts at this input here. So a resistor to ground generates the current limit for peak current limit. And the same thing for continuous. If you want a 50% continuous current limit, you use a 9.8 kilo ohm resistor to ground external of the drive, which would be 2.44 volts external of the drive. And I squared T limit, same thing. And the PWM limit is a way to control the top speed or voltage to the motor. If you have a 24 volt supply and you want to limit it to say 12 volts for speed at the motor plus IR drop, you put a resistor, 10 k ohm resistor to ground at this input, PWM input, or you dial up a voltage. So here voltage could be varied between 0 and 5 volts to limit the voltage to the motor. This is sort of a poor man's speed control. And I'm going to show you how I figured out the wiring on this motor. Again, I just hooked up the hulls in a logical manner, and then I connected the motor power wires and tried to command a small amount of current. My motor got stuck. So I swapped, in case 2, I swapped the red and the black wire, and my motor still got stuck. So I tried swapping the yellow and the red, the next combination, and the motor got stuck. And so I swapped the yellow and the black, and it went one way but got stuck the other. There was one that I thought looked pretty good. I swapped the red and the black, and it would go both ways if I commanded a large signal, but when I did a small signal, it would definitely get stuck in one direction. So there was only one correct way to wire the motor, so that small commands for current in both directions is able to commutate the motor. And of course it would be just my luck that the last combination actually worked. So to wrap things up, you've got 2 BTMs, 05520 and 09010, and there's a development kit and a connector kit for the development kit. Normally in an application where you integrate this into the system, you want to develop your own board. So there's a development kit reference design here. This zip file contains all the pad files for laying out your own board. And of course CE and mean time between failures, and some drawings, outline IGUS files for the dimensions of the drive. Well, thank you for learning about and considering the Bantam, a modern current mode amplifier, just like the old current mode amplifier.